Hi all. Today we start discussing the paper differential geometry. Uh, Differential geometry deals with the study of the curviness of surfaces in Rn. That's the general idea of differential geometry. Uh, if we have some idea of linear algebra and differential equation, we can easily follow this differential geometry paper. We start with basic definitions. These are the contents of the first module, chapter 1, chapter 2, chapter 3, 4, 5. These five chapters constitute the module 1. So first we start discussing module 1. So the first chapter is level sets and graphs. The textbook for this course is uh, Elementary Topics in Differential Geometry by John A. Thorpe. The book is available in the department library and uh, main library as well. Uh, Module 1 consists of graphs, level sets, vector fields, the tangent space, surfaces, vector fields on surfaces, orientation. This consists of chapter 1 to 5 of the textbook. In module 2, we have three chapters, chapter 6, 7, and 8. That consists of Gauss map, geodesics, parallel transport. These three chapters are in module 2. In module 3, we have again three more chapters, 9, 10, and 11. Consists of Weingarten map, curvature of plane curves, arc length, and line. And finally, we have module 4, consisting of curvature of surfaces, parameterized surfaces, local equivalence of surfaces, and parameterized surfaces. These are chapter 12, 14, and 15. Chapter 13 is an independent chapter, so we have excluded the chapter 13 in our syllabus. These are the reference books. You can refer any of these books. We can start with chapter 1, level sets and graphs. Level sets, the definition of level set is it's a function. Level set is defined for a function. Okay, if we're given a function f from u to r, u is a subset of rn plus 1. Its level sets are the sets f that is denoted by f inverse c, defined by f inverse c is equal to x1, x2, etc. xn plus 1 belongs to u. U is the subset of rn plus 1 with f of x1 plus x2 plus etc. Xn plus 1 equal to c. So corresponding to any c, you can define level sets. If we choose arbitrarily c, the level set may be empty, and sometimes it contains exactly one term or 1 point or 2 point. That is an arbitrary form for that level set. Okay, and this number c is called height of the level set, and f inverse c is called the level set height. Since f inverse c is the solution set of the equation f of x1 plus x2 plus etc. xn plus 1 equal to c. So the c is called the height of the level set. Next we have another definition, graph. The graph of a function f from u to r, u is again a subset of rn plus 1. Okay, so that is the subset of graph is always a subset of rn plus 2. So if we consider a function f is f of x equal to some sin x, then the graph of sin x is resides in R2. Okay, even though the function is from R to R. Similarly, the function from u to R, u is a subset of Rn plus 1. Then we can say that this graph is a subset of Rn plus 1 too. Okay, more precisely, that is a set of Rn plus 1 cross R. So that is denoted by Rn plus 2. Okay. So that collect the points x1, x2, etc. xn plus 2 such that f of x1, x2, etc. xn plus 1, that should be this x1, x2, etc. xn plus 1 should be an element of u with the property that f of x1, x2, etc. xn plus 1 is equal to xn plus 2. Okay, this is the definition of graph. Then these are some properties of graph and level sets. Level set can be empty. If for c greater than or equal to 0, the level set of f at height c is just the set of all points at the domain of f of which the graph is at distance c. For c less than 0, the level set of f at height c is just the set of all points in the domain of f under which the graph lie at distance minus c. Okay, these are some conventions, so we need to accept this to follow this book, or at least differential geometry course. Now we can see some examples. If f of x1 x2 etc xn plus 1 is equal to x1 square plus etc xn plus 1 square, then the level set, we need to evaluate the level set of this function at x equal to minus 1. Okay, you can easily say that the level set is defined as x1 x2 etc set of all x1 x2 etc xn plus 1. If the domain is not mentioned, you can take it as the whole Rn plus 1. Okay, yeah. Then set of all x1 x2 etc xn plus 1 with this square is equal to minus 1. Okay, so that is not possible because this function x1 square plus etc xn plus 1 square is always a positive quantity, that never be negative one. So this level set contains no points. Okay, so then level set will be empty set for c equal to minus 1. Okay, now we have another problems. You can work it out. Describe the level sets of the same function with n is equal to 0, 1, 2. Okay. Describe the level set of the function f of x1, x2 equal to minus x1 square plus x2 square, etc. Okay. So you can find the level set of these functions with c is equal to minus 1. Okay. In the first case, we never get any point in the level set, even though n is equal to 0. The rest of the examples you can find some elements anyway. If you consider f of xy is equal to x square minus y square at c equal to 0. Okay, at c equal to 0, the level set is set of all xy such that x square minus y square is equal to 0. X square is equal to y square, then x equal to plus or minus y, not the hyperbola. This is the pair of straight lines. Okay, if c equal to 0, this is the pair of straight lines, so that will give this red line denotes the level curve of this set. Okay, level set or level curve. Since this is a curve, then level set is also termed as level curve. This level curve is plotted by the red lines. Okay, if c equal to 1, we can get the hyperbola, that is also plotted using the red color. So actually that is the intersection of the surface with the plane at c is equal to 1. So this is another example. Now you have some exercise problems. Okay, so this is up to the chapter 1. So you need to work it out, all these level set, and also there are so many problems in your textbook exercise as well. So you try to solve all those problems. You try to draw the graph and level sets of those functions. That is problems discussed in the exercise. Okay.